Okay, so the next Algebra 1 skill we're going to review this week is linear functions and how to graph lines. And then we're going to talk about how we can change linear functions in order to graph them. So the two forms of linear functions that you need to know for this week is slope-intercept form and standard form. I think slope-intercept form is the one we are all most familiar with, where we know m here, this number is the slope, also known as the rise over the run, and b is the y-intercept, okay? Standard form, if we plug in 0 into certain values, it helps us find the y-intercept or the x-intercept, but it doesn't give it to us in the form that is in. So what's going to happen is we might be given stuff in standard form, and if I want to graph it, we're going to change it to look like slope-intercept form. So before we jump into converting and changing it, let's review how to graph linear functions. So one, graphing from slope-intercept form is the easiest. So I would say the first step after it's in slope-intercept form is to identify the slope and then identify the y-intercept. So in this problem, the slope is -1/2. I'm going to color code stuff. And the y-intercept is 8, okay? 0, 8. Step 2 is then we graph the y-intercept. And then step 3 is use the slope to plot following points. And remember, with graphs, we always go from left to right, okay? So it said our first step was to plot the y-intercept, so +8. So since my slope is -1/2, that means the rise, and in this case our rise means we're going down over run, since it's a -1/2. So if we're going from left to right, we go down 1 over 2. 1, 2. So then that way we're reading it this way. Down 1 over 1, 2. Down 1, 1, 2. Down 1, 1, 2. And then we can keep doing that. And then we can go reverse 2. Up 1 over 2. And that's going backwards. And then you would just connect those. And there is graphing a line. So what we would do here is I want to graph these two. So if I look at these two equations, they are in standard form. And remember, I want it to be y equals mx plus b. So if we look at this first one here, I need to get y on its own, right? Again, I want to get it isolated, so I have it written as y equals mx plus b form. So to do that, I'm going to draw a line here, is I'm going to get rid of the 8x. So I'm going to subtract 8x. Now when I subtract 8x here, the 9 and the 8x cannot combine because they are two different terms. So I'd write it as 9 minus 8x, okay? Now y is on its own, so it's in slope-intercept form. Or, because we usually put the mx term first, we can write it as y equals, you keep the negative sign with the 8, -8x, and then it would be plus 9. So they're the same equations. This one is just in slope-intercept form, okay? So we're going to do that with this one as well. So again, first thing we're going to do is we're going to try to get y on its own. So I need to subtract the 11x. So we have -8y equals, I'm going to write -11x plus 3. Now this one has an extra step. The y isn't on its own yet. We got to get rid of that -8. So I'm going to divide by -8. On this side, we have to remember to divide each one by -8. We can't do just one. We got to divide everything. So when we do this, we get y equals, well, negative divided by a negative is a positive. I'm going to leave it like a fraction. We're not going to graph this one because that would be mean. And then 3 divided by -8, well, positive divided by negative would be a negative. So this is it in slope-intercept form. So again, if we want to graph this, how can we graph the following equation? Step 1 is to convert it into slope-intercept form. So I'm going to subtract 4x. So 3y equals negative 4x plus 12. Then we're going to divide each one by 3. So again, when we have the slope here, I would leave it as a fraction so it's easier to graph, and then that way we can identify the rise over run easier than if it was written as negative 1 1/3. Okay, so I would leave it as negative 4/3. So our slope is negative 4/3, and our y-intercept is positive 4. So I'm going to graph positive 4, and then we're going to use our slope. So I'm going to go down 4 over 3. And I usually like to do 2 or 3 extra points after I graph my y-intercept in order to draw my line. So if you want to pause this video and rewrite these into slope-intercept form, that would be a good idea, so to practice that skill. So I'm going to go through and solve this really quick. Minus the 5x. I'm going to divide everything by negative 3. So again, we're going to have that fraction, but since they're both negative, it turns into a positive 5/3. And a positive 12 divided by a negative 3 is a negative 4. So that's the first equation we're going to graph. I'm going to rewrite it here. I knew that was coming up, so that's why I did that. Okay, and then my second one here, we're going to add 4x this time. Right, so the reason why we do that is so they cancel out. Whoops. So 2y equals 4x plus 10. Divide all of them by 2. So then we get y equals, well, 4 divided by 2 is 2x, and then plus 5. So that's the second equation we're going to graph. Oops. All right. So then now we're going to graph them. So for this one here, we start at negative 4. And since it's positive, we're going to go up 5. 1, 2, 3, 4, 5. And then over 3. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3. Up 5, 1, 2, 3. Okay. So there's the first equation. And then the second one, we start at positive 5. And then remember here, it's 2 over 1. So we go up 2 over 1. Up 2 over 1, up 2 over 1, backwards to 1. There we go. And then that would be how you would graph linear functions, whether they're from standard form or slope-intercept form.